Good evening. Welcome to Topics. I'd like to introduce my guest this evening, Eugene Mallove. Welcome to the program, Gene.
Welcome.
Over the years, Gene has been responsible for lining up a number of our science guests, from Ian Hutchinson to Gordon Pettengill from MIT, and we came across a book, and finally we meet after all these years. The book is entitled Fire from Ice, Searching for the Truth Behind the Cold Fusion Furor. And it's published by John Wiley & Sons Incorporated, and it's a pretty in-depth look at the original and continuing furor around the Pons and Fleischmann claims of discovery of cold fusion out in Utah. And it's rather a provocative book in terms of some of the conclusions that you draw and the places that you go relative to this thing not necessarily being what it was portrayed as during the whole furor by the institutions. So let's try and start from the beginning. First of all, let me give Gene's credentials. He is a graduate of Harvard with a PhD in air pollution control engineering, and he also possesses a BS and master's from MIT in aerospace engineering. So let's start with briefly fusion, hot and cold, the differences.
Hot fusion, which is something that researchers have been pursuing for decades now, about 4 decades, is the promise of taking hydrogen, special kinds of hydrogen from the ocean, from any water. Water is H2O, and there's lots of special kind of hydrogen in that water called deuterium, an isotope, a rare form. Putting it together in very high magnetic fields, stripping off the electrons around the atoms, and at millions and millions of degrees, banging these nuclei of hydrogen together to attempt to form things like helium and tritium and so forth. And getting vast bursts of neutrons out, or vast fluxes of neutrons out, which then can be used to obtain heat. Okay?
Make steam, produce
Make steam, right.
Okay.
A new type of nuclear energy, mimicking, in a way, the stars. That's hot fusion. Now, the nearest possible commercial application of this technology is believed, even by its proponents, to be about 3 decades in the future. And it's a noble quest, and I've been fascinated by it since I was a kid, in fact, and read some of the earliest writings about hot fusion. Now, in 1989, Dr. Stanley Pons and Martin Fleischmann at the University of Utah in March made a fantastic announcement that everyone was shocked by. They said that in a tabletop experiment using heavy water, which has that hydrogen isotope that I just referred to, and a palladium metal rod and a platinum rod, and passing a current through and getting the deuterium of the heavy water into the palladium, somehow they were able to generate, they claimed, excess power. In other words, more power coming out of the cell in the form of heat than was going in terms of the electricity. All right? Now that was a remarkable claim. It was certainly something that went far beyond what the hot fusion people had been able to do, and it was in an entirely different environment. And in fact, everyone knew on that very day that if that reaction was really fusion and it was working in the same way that hot fusion was working, then Pons and Fleischmann would be dead. No question about it, because all the neutrons from that conventional fusion reaction producing watts of power, or a fraction of a watt of power, would have killed them. No question. So it had to be something else, and in fact, Pons and Fleischmann said in their paper, their first paper, which they regrettably did not release on that very first day, which I fault them for in my book, Fire from Ice, they said they didn't understand it. And in fact, to this very day, we don't fully understand what's going on. But we do know this. Enormous numbers of laboratories now, at least 100, perhaps more, probably more than 100 laboratories around the world have had some degree of positive replication of the Pons-Fleischmann experiment, including heat, including nuclear particles of some kind, such as tritium, neutrons, radiations of various sorts, charged particles. It all adds up to a very suspicious new phenomenon, which is not well understood. But because something is not well understood, I repeat, it does not mean that it doesn't exist.
Well, let's go back a ways now.
Okay.
And you mentioned earlier that the hot fusion portion of it has been investigated for 30, 40 years, but there's also been hundreds upon hundreds of millions of dollars invested in this.
Billions.
Billions. Now, obviously, the disadvantage, or the advantage of fusion versus fission is that there is no the fuel problem. I mean, there is no nuclear problem with waste in terms
No,
of
that's not strictly
plutonium,
true.
things of that sort.
Not strictly true, but almost true, in the following sense. The main advantage of fusion, whether it's hot fusion or cold fusion, is that the fuel supply is infinite
Unlimited.
and essentially free. Now, indeed, it takes a gallon of heavy water with, instead of H2O, D2O, with that special hydrogen isotope that occurs rarely but easily extractable in water. That gallon of heavy water, which would help to fuel either a cold fusion or a hot fusion reactor, costs about $1,000. But look at this. In order to fuel a 1,000 megawatt typical size electric power plant, it would require a train about 250 miles long of coal cars.
For the year?
For the year. It would require 7 super tankers full of oil. It would require about 7 or 8 tractor trailers full of uranium oxide fuel rods. If it were a fission reactor like Seabrook or Yankee Rowe or what have you. If it were a hot fusion reactor or a cold fusion plant, let's presume that we understand that cold fusion may use deuterium, much as hot fusion would use deuterium. We're not absolutely sure, but the scientific community of people who pursue cold fusion are getting to be of the opinion that deuterium is part of the fuel. It would require only a pickup truck full of heavy water,
of 1,000
megawatts. Now, you said the nice thing about fusion is that it doesn't produce any waste. Hot fusion does produce waste, but if you want to ballpark it in terms of the relative threat, as it were, in terms of how much radioactive materials are produced by hot fusion versus current fission power, it's something like 1/100th of the problem. Still a problem, and there are many more problems to hot fusion, by the way, even if it ultimately gets going.
Well, let's get to one of the other problems significantly in the design phase, in the magnetic bottle technique, which is currently most popularized in how they're going to hold this mass of fused hydrogen that's creating this heat. That is the problem currently now from an engineering standpoint in terms of making this thing on a broad scale.
The engineering problem is very complex in hot fusion. It involves typically now tokamaks, donut-shaped cavities which are evacuated to very high vacuum, and then a small amount of fuel, in this case deuterium. They also put tritium, which is another kind, a radioactive form of hydrogen, mixed together in 50-50 proportion, and then scrunched down in various ways with all kinds of complex magnetic fields, electrical fields, radio frequency power that has to be injected to strip the electrons off, and so forth. It's a very tricky business, but they have managed to get these systems, these tokamaks, which now number something on the order of 100 have been built around the world as experimental prototypes. They are nearing what you would call break even. That is, as much electrical magnetic power being put in as may come out when they put the final tritium fuel in. However, far from a practical device. The conditions of vacuum, the instabilities in this hundreds of millions of degree plasma make it a very finicky machine at best. By the understanding of everybody, no one is denying this for a minute. It's a tough engineering problem.
Okay, what I'm setting up here is the basic conflict that arises. We have all of these enormous complex problems relative to hot fusion, all of this enormous amount of money and great brain power that's dedicated to it. Then along, physicists primarily, then along come 2 chemists from the University of Utah.
And the University of Southampton in England.
Right, was Pons.
Martin Fleischmann, the other way.
And say that we've gotten these results basically out of a beaker on the top of a table in a laboratory. So from day one, the other side is going to be skeptical.
Highly skeptical. And in fact, I was highly skeptical. I didn't believe this myself. I was shocked. I wanted to hear more about it. I was delighted to hear more about it. I kept pursuing the story and finding all its details out, and I kept being intrigued by the increasing positive results that never went away. Yes, they were irreproducible in certain ways, And some problems still exist, but I began to see that no way were we going to erase all of the experiments. And whenever in science you see an anomaly, that is something that conflicts with your normal understanding of how things work. That's the time to take action and really thoroughly investigate the problem. The shocking thing about this story is that the combination of the hot fusion community and the skeptical, and I would even say bigoted, physicists and others, and certain very problematic media types, who combined forces, not in a smoke-filled room, but in an evolved conspiracy, you might say, to kill this, to make it seem as though this is a joke.
Okay, well,
And
you
it's
have
not.
a quote there that you referred to from Arthur C. Clarke, who's a noted science fiction writer and
An engineer.
engineer, a variety of different things, actually, Arthur C. Clarke. But you have a great Clarke quote in the front of the book, in the preface, and he identifies that as the preconceived idea of impossibility, and that is what you lay the problem at the doorstep here.
That's right.
As a result of.
It's very common in the history of science for even good scientists to say that something is impossible. Flight was stated by the famous astronomer Newcomb, even just a few years before the Wright brothers flew. He said, it is impossible for man to fly with a heavier than aircraft and so forth and so on in a controlled flight. And lo and behold, they did it. Then when they did it, and he found out about it and it was ultimately proved, and it took many years, by the way, for people to really believe that flight had been accomplished, 5 years, something like, before that happened.
Some still don't believe we landed on the moon.
That's right. Well, Newcomb said, well, he'll never put a passenger on board. Okay? Rutherford himself, who investigated and was a pioneer of the very nucleus of atoms, he found out that there was such a thing as a nucleus. He said that nothing would ever come of nuclear energy, that anyone who was talking about getting energy out of these nuclei was talking moonshine. Okay? Over and over again in the history of science, we hear skeptics who should know better. And in the case of cold fusion, whatever it turns out to be, and I'm convinced it's a nuclear reaction of some kind, a new character, and there are, by the way, theories now to explain it. All right? It's not as though I'm just saying, and others are saying, of the hundreds of scientists who are still investigating this, that, oh, we just think it may be nuclear. There's a lot of reason to believe that it is. The energies coming out per atom are much too high for any known form of chemistry. That's the basic bottom line.
Now let's go to Fleischmann and Pons here and talk. And thinking about Clarke's quote on the preconceived idea of impossibility, Fleischmann and Pons helped that process by the way they came to market. Not the way they came to market, but the unusual way they brought their research to the attention of the public. I mean, there was no presentation of information to normal scientific channels, journals, or peer review.
Well,
why?
Let me just explain. It's a very complex story, longer than could be described really on this show. You could devote the whole show to that complexity of the events that led up to that announcement. To some extent, there's no question, they were pushed into that announcement. They really didn't want to announce it then. There was something like 18 months more work that they felt they really wanted to do before they made any sort of announcement. Now, there were patent considerations and so forth, and there was competition with another group that they had found out about.
At BYU.
At Brigham Young University, amazingly. Only 45 miles away, Steve Jones, a physicist, who was working on another kind of cold fusion for years, which is a more conventional and fully understood kind of cold fusion called muon-catalyzed fusion. He had some ideas which were similar to theirs, although he didn't believe and doesn't believe today in the excess heat that's coming out. But nonetheless, they announced, okay? But by the way, they had submitted their article for journal publication, and it was accepted before they made the announcement to the Journal of Electroanalytical Chemistry, all right? Now, what I do seriously fault them for, though, is on that very day that they announced, they should have had a stack of scientific preprints for any scientist in the world who wanted a copy. They should have gotten a copy. Absolutely. And the other thing was embodied in their paper. They did have errors in their paper. I don't have problems with the fact that there were errors and mistakes, because any revolutionary discovery may well have mistakes and misinterpretations and problems in its first paper. And it was a rather sloppy paper thrown together. However, its heat results have stood the test of time. But what they should have said very high up instead of way down in the text, they should have said, we don't understand this at all. We believe that it's a nuclear process, because how can you get so much energy out of a system without it being nuclear?
Well, and the presence of tritium and neutrons.
Well, they did
also,
claim to have tritium, yes. Now, they were wrong on their neutron measurements, as it turned out. They may have been correct on their tritium measurements.
But my point here is that a chemical reaction could not have produced either tritium or
That's
neutron,
correct.
although could have produced heat.
Could have produced heat, but not heat in the amounts that came out in that experiment and in subsequent experiments which have been successful in duplicating their work.
Which
and
was
in fact,
a 4-to-1 ratio?
way beyond that in many cases. Let's just talk about the basic problem here. If you have a system with a bunch of atoms, such as palladium rod and heavy water and so forth, typical atoms chemically stuck together with their electron clouds stick together with a certain energy, which scientists call electron volts, several to 10 electron volts per atom. All right? Now, if you completely vaporize a system, get rid of, boil it, as it were, it takes a certain amount of energy to do that. The energy of coming apart of all of these atoms, these tinker toy pieces just being pulled apart due to their stickiness together, due to the electrical forces of their clouds of electrons. The kinds of energies that have come out per atom in cold fusion experiments add up to hundreds to thousands of electron volts of energy per atom. So it's way beyond normal chemistry. Now the skeptics say, oh, they've made mistakes. There's a problem. They've stored energy in advance, and then they release it, and so forth and so on. Yes, on day one, and in the beginning, this was very much a concern, very much a question. But now it comes to pass that certain good laboratories that spent, like Stanford Research Institute and people at Texas A&M University, Pons and Fleischmann themselves now have really very clean results. They get out energies which are far beyond chemistry, and there's no mistaking what's coming out.
Well,
there are no
explain
bookkeeping
to us-
errors anymore.
But explain to us the problem in terms of the public reaction. Okay, Pons and Fleischmann come out, they're immediately set upon,
Assaulted.
attacked by the
Called frauds.
primarily the
frauds.
physicists
Yes.
and primarily the big money institutions.
You bet.
Now,
Big money in hot fusion.
big money in hot fusion, yes. Now, Georgia Tech and A&M came out early with replications, but then retracted
Right,
them.
they had mistakes, they had errors.
But what
Some
happened?
of their groups.
Identify what happened in the immediacy following.
In the immediate month or two following the announcement, there was chaos, okay? Because of their the very strong scientific credentials of Pons and Fleischmann.
As chemists.
As chemists. Martin Fleischmann's a fellow of the Royal Society. No one could deny that these were serious people, okay? And they had good scientific backgrounds, okay? So, therefore, they were making a claim that looked simple enough for lots of people to duplicate. And lots of people all over the world, literally thousands of groups all over the world, tried to reproduce it. Some ended up being very frustrated and not getting results. Others got results and subsequently went on and continued to do research in the field and continue to this very day to do research in the field in India, in China, in 5 U.S. national laboratories and so forth. But in the beginning, there were lots of false starts. People jumped the gun. A guy at Georgia Tech said, oh, I found neutrons. He had a faulty detector, temperature-sensitive detector. People at Texas A&M, one group there, said, oh, we have heat. It turned out they had a loose wire. That gave the field a very bad name. Then later on, worse things happened. One journalist claimed that deliberate spiking of tritium into some experimental cells at another group at Texas A&M had been done to make it look as...
Fraud.
Literally, fraud was being accused, or the high likelihood of fraud. And it appeared in a major journal. And then one researcher who said they had tritium got scared and backed off on his own results and said he had probably a contaminated supply of palladium to begin with. It turns out his original results were probably fine, and his retraction was the wrong thing. It became chaos, and it gave the field a bad name. And it didn't help at all that there was literally an orchestrated attempt to kill this on the part of very senior people at the Department of Energy, on the part of many people, including MIT scientists, I regret to say, at my alma mater, who literally took reporters, gave them a bill of goods, and said, we think it's a probable scam, or a possible scam, should I say.
Despite Pons and Fleischman's credentials, it was a possible scam.
A possible scam, yes, and that they were doing schlock experiments. You know, schlock science is what the term that was used. And then later,
bad for a serious researcher to hear that term.
Right, and then later on, some of these researchers denied that they used these words, I regret to say. And nonetheless, what happened was there was a ball of contempt that got rolling against Pons and Fleischman. The media jumped in. The worst offender of all in the media was the editor of Nature magazine, a very respected journal, scientific journal, very prestigious, carries a lot of weight with all other journalists. When he wrote it off, when he wrote vituperative editorials and essentially said it should be mocked, that was the end of cold fusion for many other journalists, and even to this day. Jerry Bishop of the Wall Street Journal was one of the major exceptions. He continued to write objectively. Guess what happened? This shows you how the war against cold fusion has proceeded. He won an award, fair and square, for his 22 initial cold fusion articles. The very society, the American Institute of Physics, that awarded, that had this award, and it was fairly agreed upon by the panel of judges, they tried to disparage it. They said, well, at the award ceremony, we know you're a good journalist in general, but you made a terrible mistake in this case, and we really feel a little funny about giving you this award, but here it is anyway, and make sure next time, Jerry, when you write about cold fusion, that you tell everyone that it's nonsense. Can you believe? And in fact, the head of that the Society's publicity office, Robert Park, whose name is going to live in infamy in this field, he didn't even attend the ceremony. He normally would. That's the same man who had the gall to call the first annual meeting of cold fusion in the University of Utah 1 year after the announcement. He had the gall to say, it's a seance of true believers. He wasn't there, he wasn't reporting it, just like Nature magazine continues not to report positive results in this field.
Okay, where are the big players now?
Okay.
And at this juncture, you've got Princeton, who has the largest...
Oh yeah, hot fusion.
Yeah, largest. Sure. MIT, which we, being Massachusetts persons, so we like to think it's world-renowned in
It's the
these
largest
areas.
laboratory on the MIT campus, the Plasma
Stanford,
Fusion Center.
Where are all of the world-renowned physicists in terms of their objectivity during this chaotic period?
Okay. By the way, some physicists really believe this. Professor Peter Hagelstein at MIT has a wonderful theory that might be right, for all I know, to explain it. He continues to be interested in the field. Professor Julian Schwinger, who shared the Nobel Prize with Richard Feynman, endorses my book on the cover. He says, Mallove's book shows the truth implicit in a provocative variety of experiments. Okay? And there are many other physicists in Italy and elsewhere who believe this. However, the majority of physicists in the United States aren't even looking at the data. They're not even looking. They don't want to waste their time, as one said to me from MIT after helping to kill an article that was to have been published in the major magazine at MIT. He said, I don't want to be bothered by this. It's all junk. Click, goodbye. They don't want to look at the data. And I regret to tell you that they forgot the basic principle of science. If you don't look at the data and respect the data, you don't go forward. And I say to these physicists right now, who may be laughing at me, and that's fine, fine friends, wait until the day comes when it finally gets adjudicated, as it will. And remember, dear physicists, in 1911, superconductivity was accidentally discovered and was not explained for over 50 years. In 1986, 87, high-temperature superconductivity was discovered virtually inadvertently and has not been completely explained.
But it's been used commercially
but
without
it's being
explanation.
used commercially. And I believe it's possible that cold fusion will fit into that same category. We may not understand it completely for a while. The understanding is getting better, but we will use it commercially. And if I'm right, and I have no reason to believe that I'm wrong, this will revolutionize the world.
All right, we've got about a minute left, and prognosticate for us, when does this come into play? When do we see more public awareness, more positive things? What's going to happen in the future?
Within the next year, I suspect there will be many more better experiments coming to light. And I'd say within this decade, we will see some very startling applications. I certainly hope so. And one could always be wrong, and one would always agree to admit one is wrong. But I don't personally see how hundreds of excellent experiments today can be systematically all wrong.
And
some can be
discredited.
wrong, but they're not all wrong. And there are some that are so good, they're probably the right ones, and they're very impressive. This is a new form of energy, and for all practical purposes, it's infinite, it's clean, it's benign, it's great. Read the book.
It's revolutionary. The book is entitled Fire from Ice, Searching for the Truth Behind the Cold Fusion Furor. Our guest today has been Eugene Mallove. He is the author. It's by John Wiley & Sons, Inc., available in good bookstores. Thank you, Gene.
You're welcome.
Thank you. Have a pleasant evening.